scientists, it's Jessica Power, one of the science curriculum coordinators at Kansas City Public Schools. Scientists, the last couple of weeks we have talked about weather. We talked about what is weather, the types of weather that we see. We talked about meteorologists and what they do for their job. And we also talked about weather data. We collected weather data, we turned some of that weather data into a bar graph, and we looked and talked about how scientists or meteorologists use that weather data along with other maps to predict or forecast our weather. Well, scientists, we're going to add to that this week. But instead of talking about weather that changes day to day and hour to hour, we're going to talk about seasons. Now, we're currently in fall. So there's a lot of things that are happening during the fall. But scientists, our year from January to December is actually cut out into 4 different seasons. And those seasons are right behind me. So let's take a look. Scientists, we have spring, summer, fall, and winter. And right now, we're in fall, as we've talked about. So you might notice that the trees around you, they've started to go from green to yellow to orange to red to brown, and those leaves are slowly starting to fall off the trees. You also probably noticed that plants that were thriving or flowers that were growing during the summer, they're not growing anymore. And as we start to get closer and closer to winter, our trees look more and more like skeletons because there's no leaves on them during the winter. Well, what are these seasons? What do we see during these seasons? What do we experience? And what is a season anyways? Why are there 4? That's what we're going to talk about today, scientists. So let's go back to this definition. Now, this definition might be a little confusing to start with, but I promise by the end of our time together today, you will understand seasons. Here we go. Scientists, seasons are parts of the year that have different amounts of daylight. Daylight, let's think about that. Scientists, in the summer, when you went to sleep, it probably was still light outside. And when you woke up, it was light outside. Now, scientists, in the wintertime, when you wake up, it's dark outside. And when you go to sleep, it's dark outside. Which tells us that there are different amounts of daylight, or the hours of day that we can experience sunlight changes. Now, scientists, our seasons have everything to do with the amount of daylight we have. In fact, you can look at a data table, which we're actually going to create next week, and predict what happens to the sunlight the further into a season we go. Let's go back to our chart to get an overview of the seasons. So scientists, I'm going to start with fall because that's where we're at right now. And it's a little bit easier to understand the seasons if we start with the one that we're currently in. So scientists, we're in fall. And as I talked about, you probably see the changes that are occurring during fall. We talked about the leaves that come off the trees. Those leaves change colors. The plants that you usually see during the summer and spring no longer around. And scientists, you even may start to notice that you see fewer and fewer animals. That's right. Some of the animals start to hibernate, or they start to not spend as much time wandering around outside as they usually do. Now, during fall, there's a couple things that happen. The first thing that happens is that every day of fall, we experience or we get less and less sunlight. That means when fall started, we had a lot of sunlight. But now, as we're getting towards the end of fall, we don't have very much. So fall is really a season where we start to see a huge change in the length of the time the sun is out during the day. And that impacts our temperature, it impacts our weather, and it impacts what happens to the plants and animals in the environments around us. Now, scientists, also during the fall, it gets colder. In September, you probably were still wearing a t-shirt, maybe shorts, maybe if you had to, a light jacket. But scientists, as we get closer and closer to winter, it's getting colder, which means we have to put on coats, we have to sometimes put on gloves, We have to make sure we're not wearing sandals, right? Because the colder it gets, the more we need to stay warm. So even during fall, we also see a change in temperature. Now fall turns into winter. And in the wintertime, scientists, it's really cold. And I put on this poster, scientists, it's dark. Because we don't get very many hours of daylight. The sun starts to set around 4 or 5 o'clock. By 6 o'clock, it's dark. So we have a lot of dark or nighttime. We typically see snow as a type of precipitation. And we even get ice. I could have added sleet to winter. I didn't. I thought snow and ice would be fine for our weather or precipitations that we experience. Now you'll notice here that there are no trees, no leaves on those trees. And in the wintertime, you'll see that. Now there are some trees like evergreen trees. And those actually have little needles on them, like pine trees. So pine trees have little needles, and those needles are different than our leafy trees. They're a different type of tree. But for the most part, majority of the trees that we have around Kansas City, they're gonna lose their leaves. And during the winter time, those leaves stay off. Now, once we get to the end of winter, we start to go into spring. Now, spring is similar to fall, but spring is the opposite, meaning the opposite thing happens. In the fall, it gets colder outside, and we get less and less sunlight. But in the springtime, it gets warmer outside. We get closer and closer to summer, which means we get more and more sunlight. In the beginning of spring, it's still a lot of darkness. There's still a lot of nighttime. But by the end of spring, we have mostly sunlight during the day. You'll start to notice that the trees, some plants start to grow and come back. The environment looks more green in the springtime. And then finally, scientists, we transition into summer. And during the summer, we see the most amount of sunlight. Like I said at the beginning of our time together, when you wake up, it's sunny. When you go to bed, it's sunny or light outside because we experience more sunlight. We see lots of sunlight. We typically see some thunderstorms, right? It's really humid, meaning there's a lot of water droplets in the air. And it's typically really, really hot. So scientists, summer and winter are similar because they're extremes. Meaning in the winter, it's really, really cold, and in the summer, it's really, really hot. Now, spring and fall, they're also similar because they're changes. There's lots of changes that happen during those seasons. Again, in fall, the leaves start to fall off. It begins to get colder, and the temperature gradually decreases during the fall. And in the springtime, we start to see more sunlight, and the temperature gradually increases to get us closer to summer. So scientists, we have 4 seasons. We just talked about the description or what each season is like, but I'm going to go back to our definition. Because if you've noticed, I've talked a lot about sunlight. I've talked a lot about the amount of light that we have during the course of a day during each season. So our definition, again, scientists, is our seasons are parts of the year that have different amounts of daylight. And by daylight, I mean hours of the day that we experience the sun. Now, scientists, I'm going to go and I'm going to challenge us for the next couple minutes because I'm going to show you a globe. And that globe represents the earth where we live. And scientists, I'm going to show you kind of why we have these seasons. So scientists, here's my globe. And you will notice that when I put my globe can spin. Okay, it spins around. But scientists, you also might notice that there's a red line that goes around this globe. Now scientists, in a typical sphere, this is a sphere, it's a circle, a 3-dimensional circle. This red line if I wanted it to go perfectly in a straight line around the globe, I would move the globe like this. You have the North Pole, and you have the South Pole on the very bottom. Now this red line, scientists, that goes around the globe that you see on here, this represents the equator. And the equator is the very center of our Earth. And it's an imaginary line. Now, scientists, this isn't how the Earth is in space. It's not straight up and down with the North Pole pointing straight up and the South Pole pointing straight down. And the equator doesn't run in a line like this. In fact, in space, our Earth is tilted. Did you notice what happened? The equator now looks like it's almost a little bit diagonal. Our North Pole is over here, and our South Pole is now down here. Now we could draw a line from our North Pole to our South Pole. Pretend I put a pole in it, right? If I put a stick or a pole that goes through the North Pole to the South Pole, it would make a diagonal line. Now this is called a tilt. So remember how I had the equator as a nice straight line that went side to side? The Earth sits on a tilt. And as the Earth spins, different parts of the world get different amounts of daylight during the year. And those different amounts of daylight during the parts of the year are why we have seasons. So scientists, because our Earth sits on a tilt, right? That means it kind of sits diagonally. That means different parts of the Earth experience different amounts of daylight or sunlight during different parts of the year. That's one reason why right now in the fall, it's starting to get darker and darker and darker. Because if we go back to our globe, as the Earth moves, so the Earth spins, but it also moves this way around the sun. You'll notice that in the wintertime, the part of the Earth that's really facing away or doesn't get as much sunlight, they're experiencing the winter. And the part of the Earth that gets the most sunlight during different periods of the year, they're experiencing summer. So scientists, there's 4 seasons in a year. Seasons are just parts of the year that have different amounts of daylight. Scientists, next week, we're going to take this idea of seasons and we're going to look at some more data. We're going to look at a data table that shows us sunrise and sunset times and the amount of daylight that we experience throughout the course of a few months. So I'll see you back here next week, scientists. Have a great day. Hey scientists, it's Jessica Power, one of the science curriculum coordinators from Kansas City Public Schools. Scientists, the last couple weeks we talked about adaptations. The first 2 weeks ago, I did a demo for you where we looked at different tools that I had in my house with the tongs and the spoon and the tweezers and the toothpick. And we were wanting to see what kinds of foods and how much food could I pick up out of a plate full of Mike and Ike's unpopped popcorn, dried beans, and rice. I know, super exciting. But we found that bigger beaks were easier to pick up more food, and you could eat a bigger variety of foods. And then all the way down to the toothpick, I could only pick up a Mike and Ike, and that was by like stabbing it. Otherwise, I couldn't get anything. Well, scientists, last week we read a book together about the birds of beaks to learn about how there's all these different kinds of birds across the world, really. And all those birds have different beaks that allow them to eat different kinds of foods. Well, I want to focus right now, scientists, on animals. We're going to talk about 3 topics today. We're going to talk about pollution, we're going to talk about forest fires, and then we're also going to talk about poaching or illegal hunting. Because believe it or not, scientists, there are thousands upon thousands of really cool animals on this world. There's all sorts of animals that we typically don't see here in Kansas City. Some of my favorites, like lemurs, live in Madagascar, which is its own country off the coast of Africa. And there's thousands of species of lemurs. But some of those lemurs are dying in populations for a lot of things. Their habitats are being cut down so that growers can make coffee plants to grow coffee beans. There are wildfires that are just taking over in different parts of the world. The Amazon rainforest, our largest rainforest in the world in Brazil, has been burning, and millions of acres have burned and have been destroyed. Now, there's all kinds of pollution going on. There's oil pollution, or things that happen that get dumped into our oceans, into our rivers, into our lakes. There's also pollution like plastic bottles, and those like plastic little circles, or 6 of them that hold like 6 cans together. Those get trapped and they get caught around different animals' necks. And then there's poaching or illegal hunting. And this is really common in Africa, especially on the savannah, where there's elephants and giraffes and really unique animals like lions. And what happens, scientists, is that people go in and they kill these animals as a prize, as game they call it. But what happens is that too many of these animals are dying, and they're not able to reproduce or have animal babies in a time to catch up and keep the population high for these animals. Now, I know, lions are dangerous, tigers are dangerous, but they're also beautiful and they're unique, and we need to be mindful of what we're doing in our ecosystems. So today, scientists, I want to talk about how things can happen that change an ecosystem. And when something happens that changes an ecosystem, what are those impacts? So again, we're going to focus on forest fires, we're going to focus on pollution, and we're going to focus on illegal hunting. So let's start with forest fires first and foremost. Scientists, I mentioned earlier that the Amazon rainforest has been burning, and millions, we're talking millions of acres of land have been completely destroyed. That doesn't even include the acres of land that are cut down daily to plant new plants or to build neighborhoods, things like that. We call that deforestation. But scientists, what happens? Let's talk about the forest fires. Because there's been forest fires in California this year. There's been forest fires in Colorado. And they are devastating the environment, meaning that they are causing lots and lots of damage. It's really hard to stop and put out a forest fire. It takes a lot of people, and it's dangerous work. Now, we don't always think about the animals in the forest. Scientists, the forest is home for animals. Just like you have a home and I have a home. Maybe, my dog has a home. For wild animals, the environment they live in is their home. So think about deer or beavers or coyotes. They all have a home in the forest, or squirrels or different kinds of birds. And when the forest fires come and they burn down their forest, they burn down their home. Well, now those animals don't have anywhere to live. So you hear stories of places like in Oregon or in California where they've had forest fires, Colorado, where animals start to appear in neighborhoods, like deer just walking down the street. These animals are terrified because they've lost their homes. Now, when that happens during a forest fire, animals also die because they can't get out of the forest. So when things like a forest fire occur, that decreases populations within the forest. So animal populations drop down really low. That decreases the amount of natural resources like trees that we have. And scientists, that takes lots and lots of time, hundreds of years, to get that forest back to how it was. Now let's talk about pollution. And specifically, I'm thinking water pollution. So with our oceans, our lakes, and our rivers. Believe it or not, scientists, the world's largest coral reef is in Australia. It's on the coast of Australia. And we are talking about thousands of different kinds of corals, different kinds of tropical fish, a really beautiful environment. But unfortunately, due to human pollution with oil and different chemicals being dropped into the oceans, with plastic and things that don't break down, right? Pollution, garbage being thrown into the ocean, our lakes and our rivers, we start to get what's called bleaching. And what happens is the corals that are usually brightly colored, think like really bright, beautiful colors, they slowly start to fade because they're not getting the right nutrients that they need. Corals are living organisms. They're a living thing. And so just like you and just like me, we need nutrients, we need energy, we need things to grow and survive, and corals need that too. But when you dump in pollution or you dump in fumes from boats, right, those toxic fumes that boats can put off into the water, that slowly starts to destroy and break down the coral reef. There's a decline in sea turtles right now because sea turtles they're getting caught in pieces of plastic and they choke and they're not able to survive. A long time ago, well, relatively a long time ago, there was this huge oil spill in the Gulf of Mexico, down in Louisiana, Texas, Florida area. And an oil company, there was a pipe that had ruptured, it had broken, and it was releasing all kinds of oil into the Gulf of Mexico. Thousands upon thousands of fish died because they can't drink oil, right? And now we talk about how do populations or how are ecosystems impacted because of these changes. Well, one of those things with the oil spill in the Gulf of Mexico is there were fishermen that lost their jobs because there weren't enough fish to fish, right? So you look at some of these things that happen to our ecosystems, right, our natural world, and they cause huge problems for even us humans. So not only did the fish population go down in the Gulf of Mexico, people lost their jobs. They weren't able to fish because there were no fish. And that's not an easy thing to clean up in the middle of the Gulf of Mexico, a bunch of oil that spilled. And it took a really, really long time to get it cleaned up. And the Gulf of Mexico is still coming back from that oil spill. Now, scientists, the last thing I wanted to talk to you today about things that happen to ecosystems is poaching or illegal hunting, like I had mentioned earlier. Poaching is really common in Africa on the savanna, where you have zebras and lions, you have gazelle, you have giraffes, you have elephants. Scientists, the rate at which elephants are being illegally hunted or poached is at a rate where if we can't get it under control and stop elephants from being poached, those African elephants may go extinct during your lifetime and during mine. Now, when you poach elephants, let's just keep with the elephants. Elephants are one of the biggest spreaders of different plant seeds. So elephants are responsible for dropping seeds in their droppings, and then that grows new plants. Right? And then you have herbivores like zebras and gazelle that eat those plants, right? And then you have organisms, or you've got lions, right, that eat the zebras. We know that circle of life with ecosystems. If there's not enough elephants, then there's not enough plants because we're not dispersing the seeds and growing plants. And there's not enough plants, there's not enough food for our herbivores. There's not enough food for our herbivores, they begin to die off. And if the herbivores start to die off, then the carnivores also suffer because then there's not enough food for the carnivores. So scientists, there are environmental changes that happen all of the time. And some of those changes are positive. You see all sorts of places where they're planting trees, or there's conservation farms where they're protecting, like African elephants in Africa. There's conservation reservations where they're literally protecting and breeding animals to get the population up. And that's to help save our planet, and that's to keep the ecosystems in balance. Scientists, at the very beginning of this video, I talked to you about lemurs. I said lemurs were one of my favorite animals. And there's tons and tons of species of lemurs. But some of those lemurs are critically endangered because their habitats are being lost due to people cutting them down because of things like forest fires. So as we are scientists in this country, we need to care about the environment. We need to care about the world. We need to understand that poaching is really, really bad. You're not taking a trophy home, you're killing an animal. And that animal has a really important job in its ecosystem. And when forest fires rip through different parts of our country and around the world, the impact that can make to the devastation of the animals, the loss of home, the loss of resources, the loss of food for surviving animals. And finally, with pollution, if we can recycle, let's recycle. So that way we don't have plastic bottles and different pieces of plastic bags and different things being put into the ocean and the rivers and the lakes. That's going to hurt our animals and decrease the population. Now, scientists, things happen in ecosystems, and we understand that. But there's lots of things that we can do as humans, as people, to protect those ecosystems. So yes, scientists, some of the coolest animals in the world are cool because of their adaptations that we talked about the last couple weeks. But if we want to keep those really cool animals around and allow them to be able to live with their adaptations and their ecosystems, we have to protect those environments. So be thinking about that, scientists, as you see things in the news. Pay attention to the world. We'll be back here next week. We're actually going to start talking about earth science. We're going to be talking about weathering and erosion and how landforms change. I'll see you next week, scientists. Have a great day.
Hi, I'm Erica Manian. I'm the iSpark CTE Coordinator with Kansas City Public Schools, and welcome to KCPS Homeroom. Today I have an exciting presentation for you. We are going to go on a field trip. Yes, a real live virtual field trip. The exhibit that we're going to finish seeing is at Science City. The exhibit is called Every Last Drop, and in the end we're going to have a design challenge that's going to cultivate all of our learning and all of our thinkings and all of our wonderings as we have been along this journey. So let's get started. Our objective today is going to be to develop plans that describe a program sequence of events, goals, and expected outcomes. What do you think we're going to be doing in the end? You guessed it, we are going to make a computer program. Yes, we are. All right, so here's your directions. After viewing our virtual field trip, the students will show and create a contraption that's going to collect clean snow. I know you're excited for it to snow the next time, and I want you to be ready. You are going to demonstrate how your plans are going to happen that you're going to use to create your snow collector. So you need to make a detailed drawing of how your project is going to look. So that's the first step. Draw a picture and plan it out. And then last, you're going to compare your collection of the snow that you're going to do versus how they collected water on every last drop. And see how they collect water versus how you're going to collect your snow. Then you can analyze your results of how it happened when you collect your snow and determine if you want to make modifications to your thing that you make, or if you need to go with it and see if your snow is not contaminated. All right, welcome to Science City. Enjoy this virtual field trip.
Welcome to KCPS Homeroom, and today we're at Science City. You'll be able to visit Science City with your parents, and all the young inquisitive minds can come and create, explore, and experiment with the world of science through interactive activities and non-stop fun. There's nearly 100,000 square feet of indoor and outdoor experiments, exhibits, and activities. There's something for everyone to do, from the youngest of learners, including 4 new spaces dedicated for early childhood through infants to 6-year-olds.
Engage in the learning of every last drop. This interactive exhibit entices discovery and curiosity. Gravity makes water flow down. and ultimately takes the path that it can flow. Here's the Archimedes screw. It's a form of positive displacement pump. The vortex, when the fluid is traveling around the hole, you can start to see it twirl around in that hole. We're moving over to the water table. You will see it uses slits that are able to manipulate the direction that the water is flowing. Balls and rubber ducks are then used to show where the water is flowing. When the water flows over sand or soil, it picks up pieces of that sand or soil and sometimes sediments that move it to different locations. Our water molecules are hanging from the ceiling to represent the individual water molecules and what they actually look like. Here's our table again. It helps to show the flow of the water in whatever grooves or indentations that are in our earth surfaces that constantly reshape and make those paths and the grooves that makes the water move along. You could change the slits to change the path and see how gravity takes water in a different direction. Why do you think it's important to recycle water? Do you think that we can use clean water before it's used again? And what are the limitations that we have for filtering clean water? We can use rocks and all different types of ways to filter the water. Let's take a look at all the elements of every last drop. There is the Archimedes screw again. It is able to force the fluid down as it moves along the spiral or the helix. Being able to predict the direction of the water and how it's flowing helps it be necessary so that we could find a clean water source. Here's a fun fact. Bacteria is used to clean water. Did you know that? Because they decompose dangerous chemicals, organic matter that may be in water, and so they use the bacteria to help us have healthy, clean water. How about this? Water has been recycled for civilization since the Bronze Age. And lastly, wastewater was originally used in irrigation water and to fertilize crops. Humans have been trying to purify water for thousands of years. Now, science of the season, the theme for December. Here are a few of our activities. Here comes Santa Claus air pressure. Watch Science City educators demonstrate how high to low pressure systems push large loads like Santa through narrow chimneys. Next, make and take fake polymer snow. Work with super absorbent polymer like the ones used in astronaut diapers. And finally, sew a snowflake cord keeper. While our Maker Studio educators will teach some basic sewing skills.
All right, we just finished our field trip. That was so exciting. I'm so glad you got to come along with me. You're all ready to go with your family and explore all the things that every last drop has to offer. Did you notice the ceiling? I hope you did. We're going to talk about that in just a few seconds. So now that you've gone on your field trip, think about all the things that you saw at every last drop and how you can use all of that wonderings and all of that learning in order to make your own snow contraption. All right, so at every last drop, there's a few things that I want to draw your attention to. Did you notice the ceiling? Those were just not ordinary light bulbs. Those were something that you see every day. You drink it, you bathe in it. It's water. Exactly. And if you notice, it has a blue outer shell and two small white bulbs on the end. So what do we remember about the scientific way that we say water? That water molecule is a hydrogen and oxygen. How many of each? Let's think. H2O. Yes, you're right. It has 2 hydrogen atoms and 1 oxygen. So that is why it has 2 white on the blue. That was so incredible. And I was so glad to see that and experience that while I was at Every Last Drop. And another thing that I wanted to draw your attention to is the Archimedes here. When we looked at that, it started to turn and rotate on the vortex. And the helixes that's in the middle of that cylinder, it captures all the water as it turns and allows the water to travel up against gravity. After it's at the top, it's able to fall down into the appointed receptacle. And then they have this item here in the middle. When I went to go film that, I was really nervous because it's a hollow vortex and I did not want my phone to fall inside. But when I looked inside, I was so intrigued. It just went round and round and round. Did it remind you of something that happens in nature, like a natural disaster? I thought it looked like a tornado. Have you ever made a tornado inside a 2-liter bottle? Maybe you can make one at home. And then finally, we had other different types of receptacles that we got to see at Every Last Drop, including the water table. I really liked watching the water table for all the ways that it showed how the directions that the water could go and travel based on the stilts that were there and how we can change that, and that's just what happens in nature. All right, so now we're ready to plan out our receptacle to collect snow. The first thing that you're going to do is create a drawing. It can be a quick draw. It doesn't have to be perfect because it's just getting all of your ideas onto paper. After you get a chance to look at your drawing, then you're ready for the next step. All right, first, we walked through the entryway of Science City. Then we went over to the train table, and finally we got to the Every Last Drop. When you got there, what was the most intriguing thing that you saw when you were on the virtual field trip? Take some time to remember all the waterways and how it was collecting the water, how it transported the water, how it put the water in the right receptacle. Think of how you may want to collect your water. All right, and now you're ready to make your project. Just think about you want to tell somebody, everybody, all about your adventures. Maybe you want to go in person, but you want to capture all of this on a game. Yep, that's right. You can make a game. You could use either Scratch or Scratch Junior. You're wanting to use scratch.mit.edu, or if you have a tablet or an iPad, you can use the Scratch Junior app. So let's think about how we're going to make our story on our app. We have our written story. You wrote down all of the things you remembered from your field trip. Then you think about your setting, your characters, and your plot. How you want your story to go. Think about all the elements that you may want to include in your story. Then you're ready to get started programming. This will be geared for any age group that wants to do the programming. If you're using Scratch Junior, you're wanting to have someone that is able to follow the arrows because that programming uses arrows. But if you have a reader, you're able to use the Scratch. So I would say K through 2 for our Scratch Junior and 3 through 5 for our Scratch. Let's continue. Now, we're going to have a quick review of what we learned today. Today, we use our virtual field trip to describe a plan that we could do a sequence of events. Maybe we had a goal in mind. We wanted to tell someone about our virtual field trip, and we had expected outcomes. We wanted to teach them all the things that we learned. So, how do you start your program? First, you choose your background. Decide where you want to start. You could make one of the backgrounds that they have there with a plain sheet of paper, or you can choose one of the ones they have available for you. You are able to edit those as well. They have fall, winter, spring, indoor, outdoor, country scenes, city scenes. Your background options are endless. Then you're ready to add your character. You may choose a character that is already pre-programmed in the Scratch Junior apps, but if you're doing Scratch on scratchmit.edu, you are able to upload your own picture. So try doing that so for it could be a little bit more personalized. You can add your family members, or you can add fictitious characters that are along and included in those programs. And then finally, the last step is to animate. You can make a real live virtual trip of your own in your computer program. Have your characters talk about the exhibit and all the things that they learned to do and learned about the exhibit. Maybe you're going to teach them about those water molecules. The H2O is the way to go. And finally, tell somebody, show somebody, have someone experience your program. You could share your program with us. You could tweet it out and make sure you hashtag KCPS Homeroom. You could tag me. I'd love to see your designs that you make with your computer program. Don't forget to go and see Science City. They're open and ready for you to explore and learn. And you can keep your learning going along this virtual way or in person, and tell them that you're ready to find all about every last drop. This has been Erica Mabian for KC Public Schools Homeroom. Thank you so much for joining us, and we will see you next time.
Good morning, ladies and gentlemen. It's Dr. Jones again. And today we're going to pick up our conversation of how matter is cycled through an ecosystem, going from our producers, which are plants, to our consumers, which are animals. Now, as we do each week, we have to start with the standards. Now, this time, unlike before, we're going to pivot away from our discussion of cellular respiration and photosynthesis to the actual organisms that carry on these processes. So, if you're looking at our middle school standard, the thing that I want you to see or draw your attention to is that we're really looking at food chains and food webs, okay? And we're looking at how matter is cycled through these two different scenarios. If we look at high school, we get even deeper in the discussion, and now we're really looking at, okay, so how does energy get from the sun to organisms based on the type of organism that's bringing in that energy? In addition to, as we have here, looking at the trophic levels or feeding levels in an ecosystem. Now, there's a lot there, but just stay with me. We're going to go over it in a second. So, let's recap. Remember, photosynthesis. What is it? Well, again, photo meaning light. The synthesis meaning to put things together. So we're using light again to combine atoms to give us molecules. Now, the main molecule that we're trying to, or that photosynthesis creates, are carbohydrates, these sugar molecules. Okay? Now, when we move on to cellular respiration, remember, when we talk about respiration, don't think breathing. What you want to think of is using oxygen to produce carbon dioxide, and more important, to take this energy that's in the form of a sugar molecule and convert it to ATPs, which is like the currency of a cell, okay? Again, it is like, this is your job, that's your money, and you're going to need your money to be able to do all the things that you want to do. So again, for us to do everything that we need, we have to take in energy. The energy that we're talking about right now is sugar, and that sugar being glucose. Okay? Now, how does cellular respiration and photosynthesis depend on each other? And they do. One of the things I want to show you is that if you look at the two reactions, this one being photosynthesis, and then this one being cellular respiration, you can see the product of photosynthesis is really the reactant of cellular respiration. And the reactant of photosynthesis is the product of cellular respiration. So that gives us a cyclical pattern, okay? So those are the things that we've already talked about. The other thing is, who carries on photosynthesis? And like I said here, do all organisms or do all life on this planet go through photosynthesis? No. You have to have chlorophyll. And as we said, you find chlorophyll in your plants, you find chlorophyll in some of the protists, and you actually can find chlorophyll like this in some bacteria. Now, the other side of this, cellular respiration. Do all organisms go through cellular respiration? Well, actually no. Not all organisms, but all eukaryotes. And again, I know you're like, wait a minute, eukaryotes. Let me break it down. Eukaryotes, we're talking about plants, animals, fungi, you know, I'm going to say the corny dad joke, fungi, and then protists. Now, do not get protists confused with bacteria. Main thing you need to understand is a protist, single-celled organism, but it has a nucleus. Bacteria don't have a nucleus, so that's why they're not invited to the party. No nucleus, no nachos. So, which organism starts this whole process? And that's what we're going to be talking about today. Okay? So, first of all, let's look at some people. Producers, for example. This guy, Quincy Jones. He's a producer. You definitely know what he does, right? Makes music, right? How about this guy? Rest in peace, Biggie. That's Sean Puffy Combs. Dr. Dre. And another one. DJ Kelly. But here's another producer. Yeah, that's a producer too. So here's a question. What do all these producers have in common? I mean, let's be real. Why is it that I put this on the screen and I am literally showing you guys who make music with plants? Here's why. So, every time somebody tell me that, you know, this guy's a producer, or you know, I need to get a producer, my question was, what do you need a producer for? So I had to actually look this up, because it's not like, you know, something that you just know off the top of your head. So here's what producers do. First of all, producers, they choose a song, all right? Yeah, I just said producers. Yeah, producers choose the song. Besides that, they choose all of the instruments, the musicians. Who's going to play? Who's on drums? Who's playing bass? They choose the instruments and who's on vocals. You know, everybody that can play can't sing. Everybody can sing can't play. Michael Jackson, for instance. Nope, can't do it. Prince, there you go. How will the instruments be played? One of the things that I found with Prince, rest his soul, is that if you go to a Prince concert, or used to, can't do it now because he's dead, but when you did, if you went on Monday night, you'll hear a completely different set than on Tuesday night. Why? Because he decided, you know, I didn't like the way that the drummer was playing, we're going to do this a little different. I didn't like the, you know, the guitarist, we're going to do this a little different. The other thing is what songs are going to be sung and what notes are going to be sung. When you're going to, you know, put tracks on the album. What needs to go on the album? And the most important one is when you're going to drop the album. So basically, when you look at the producer, they bring life to the entire project. Now let's talk about this plant. Producers, what do? First of all, they collect water for photosynthesis. Next, they collect carbon dioxide from the atmosphere for photosynthesis. Then they collect light energy from the sun for photosynthesis. So first of all, you know, they're getting everything together just like this. You got to get, you know, instruments, the melody, that's what they do. Then, they take all of that and they create the molecule, the sugar molecules we're talking about, from the photosynthetic process. All of this, now we have a song. They release oxygen, because, let's be real, they're not the only ones on the planet, through the photosynthetic process. And then the most important thing is they take some of that sugar that they created and they use it to live throughout the night. Now, here's why that is so important. The sun doesn't shine all the time. So, if plants couldn't have a way of making their own energy, they would die. Producers have to have money. Here's why. Just because you make a song doesn't mean that the song's going to make money. Somebody has to be the front man. So, these cats front the cash. Now, they're going to get paid on the back end, but you need somebody to front the money. You need an organism that can make its own energy when the sun is not around. And that's kind of what producers, plants do. Okay? And then they go and restart the process all over again. You're not a producer if you just produce one song, one album. That ain't a producer. No, it's not. You know, honestly, at first, I'm going to tell you, I did not consider Lil Wayne as a producer. All he had was just, you know, Young Money. Now he's actually having other people do some things. I still don't count him as a producer, but he's on his way. And if you're watching Wayne, don't come looking for me. We good? 504, love you for life. All right. Now, as far as what the producer does for the ecosystem, the producer dictates the ecosystem. Here's what I'm saying. If you're looking at the various ecosystems, you can see some of them have, you know, producers who are more complex, more complicated than others. Okay? Look at this. Mountain range. Mountain range. What's the difference between the two? This one, no producers, no life. This one, producers, life. Let's look at another one. Swimming pool. This, koi pond. What's the difference? No producers, no life. Producers, life. Last one. Moon. Earth. What's the difference? Producers. So here's what I want you to understand. If you don't have a producer, you have no life. Okay? All right. Now, how does a producer control what's in the ecosystem? So look at this. Remember the show? Everybody should. The Voice. When it first came out, each of these characters or each of these folks served a different purpose. Here's what I mean. If you want to do rock, go to Adam. If you wanted to do country, gotta be on Team Blake. If you want to do R&B, CeeLo is your person. And if you're trying to get that pop in your life, bam, Christina Aguilera. Just like these stars or these artists kind of guided the folks in the show, producers guide their ecosystem. Here's what I'm talking about. These are all terrestrial ecosystems, okay? But a mountain range is a completely different ecosystem than a tropical rainforest. But what is the difference between the two, besides the amount of water, is the organisms, the plants, the thing that actually gets the light and converts it into sugar for the entire system. If you look at mountains, you have like simple ground cover, and you can kind of see this, you know. It basically looks like I went out, threw green paint on the ground and was like, okay, good. If you think about a rainforest, you think about the types of trees, how big they are, the amount of green life that you have here, you will see, okay, you know, I get it. Now, here's the take home. Little life, little ecosystem. Meaning, you don't have that many organisms here because if you look at it, it's simple ground cover. Very simple system. But here, in a tropical rainforest, you have these complex plants, which means you can have a complex system. It's just like producers. If you have a producer that doesn't have a whole lot of money, You know, you're going to be like, back in the day when I was living in New Orleans, before Lil Wayne became Lil Wayne, he was with Manny Fresh. Manny Fresh still lives in New Orleans. And again, Manny was good. But Manny's small time. He's a little bit bigger now, but then he was small time. So the only way that you could get Lil Wayne stuff and Hot Boy stuff was to go to the local stores. But if you think about like Puffy at the same time, Bad Boy, you could buy his stuff everywhere. So again, simple organisms, simple plants, simple system. Complex organisms, complex system. Okay? Now, this doesn't just go for terrestrial systems. If you look at your aquatic systems, it's the same thing. Now, here's the thing, and this is why this is here. If you look at an aquatic ecosystem, you got other things to take into consideration. And that's the main reason why when we talk about ecosystems, we tend to deal with terrestrial ones that are on land. Because when you start talking about freshwater, marine water, transitional, yeah. But the bottom line is, in all three of these, the plants guide the system. Okay? So, here's a question that I have for you, and this is where we're going to be going in our next segment. Now that we have the plants, now that we have the producers, now what? Basically, who's eating who? I'll see you next time. Have a great day, and thanks for watching.
At Lincoln Middle School, students discover their talents and passions, where teachers plant the seeds of lifelong learning.
I am Lincoln Middle,
where excellence is nurtured. Students develop the skills to be successful in school, career, and beyond.
Je suis Lincoln Middle.
Lincoln Middle is the public school where your child will thrive and grow. Open a world of possibilities. Apply today. Learn more at enrollkc.org/Lincoln Middle.
Kindergarten is great at Kansas City Public Schools.
I know they have really good teachers. I know this is a great school.
They teach them stuff that I thought my kids would never be able to know at the age of 5.
Since deciding to send our kiddos to a neighborhood school, we've become even more of a part of our community.
Now is the time to enroll your future kindergartner for the new school year. Visit enrollkc.org today.